So welcome everybody. How's everybody enjoying today with our rainy Lubbock weather?
No.
No? It's fall-like, right? It's kind of fall-like, sort of like Seattle, right? Or instead of traveling to Seattle, you can stay here in Lubbock. Yeah. You can even go boating if you try to drive down the Lubbock roads at the wrong time, right? So it keeps things interesting. Well, today we have our last set of presentations in the Likert textbook, the last three principles of Lean, which focus on perfection and continuous improvement. So we'll have those first. Then after that, we'll have some more announcements about Project 2 and the schedule for the 2 presentations. And we'll also have time to run at least one and possibly 2 Lean simulations, so Lean games. So before we get started and hand things over to the teams, does anyone have any questions? All right, we'll go ahead and hand things over to team number 2 then.
Hello everyone, we are Team 2 and welcome to rainy Lubbock. And we will be presenting on the 12th principle, which is go and see for yourself to understand the situation, which is a Japanese translation of Kenshi Genbutsu. And myself, I am Advait Thakur, and my team members are Muzib, and we have a off-campus student, Michael Perman, and you'll be hearing his voice during the slides. So let's start. We will be giving introduction on the 12th principle, followed by the 3 case studies. One by Michael. The first case study will be by Michael. The second will be by me, and third will be by Muzib. And then Muzib will be concluding, and then we will have a question answer session if you have any questions. So let's start with the introduction. So the introduction, let's start with lean manufacturing. So as we all know that lean manufacturing is a way of elimination of waste, and that it's when and every company strives to reach a steady state to eliminate the waste and achieve lean manufacturing. And so the production system implemented by Toyota, as it goes by the name, is the Toyota production system. And the management philosophy behind the Toyota production system is called the Toyota way. So, next slide. So as you know that the lean manufacturing is pioneered by Toyota, and we'll be discussing about the 12th principle, which is go and see for yourself to understand the situation, and which is a Japanese translation of Genshi Genbutsu. And so Genshi means actual location, and Genbutsu is the actual materials of the products. So this principle, like all the principles, even this principle has been developed over the time. And so let's discuss more about this principle. So one of the example, like as the name suggests, it's like just going to the shop floor or to the workplace and seeing what the problems are, what the errors are, and fix it. So one of the example which relates to in a company is like collecting of data, and then at the end process validating the data. So at every step there are engineers, the testing engineer, the engineer who collects data, then there's a validation engineer. So the data is transmitted from one level to another, and every engineer uses his own statistical method to derive equations and model the system. In this, he might consider some data as an outlier, and at other stage, the other engineer might consider some data as outlier. So there is always a loss of data where the model equations changes every time. So Leica wants to just say that to prevent this loss of data and to achieve the best model equation for any system, the engineer who is the validation engineer, or the management which decides what decisions have to be taken, should see the data firsthand, if not all the steps, but at least the data where it originates from. So one of the other terms related to this is the Gemba management. Gemba is same as Kenshi Genbutsu, where Gemba is called the actual place. So when it says that when a problem arises, one must go and see what the problem is. Usually we are we are like any company is used to solving problems on phones or telephones or on Skype or conference call, where the engineer who's working in the plant tells up what the problem is, and the engineer who's design engineer or the maintenance engineer usually tries to fix it online, where he says just go and do this, try this. Instead of that, I mean, it's not possible every time to go and see it, but as long as it's possible, if it's possible and reachable, then the problem can be gone at rest at that time. So at that point, there could be some problems which require temporary fixes, where it can be the problem can be fixed temporarily, and if that point that problem can, and the engineer can go and see, and then after some time go and fix it, like to resolve the problem again and prevent it from occurring anytime in future. So the next slide will be explained by Mike.
The previous slides here, Genchi Genbutsu and Gemba, go and see for yourself to thoroughly understand. Toyota places a high emphasis on personally going and observing the operations and analyzing what you see in order to get a deeper understanding of what's going on. And by doing this, you're able to find the true issues that are being faced there on the shop floor, and institute constructive changes to help resolve those issues. You're also able to think and speak intelligently to others based on information that you've gained firsthand. This avoids what we've discussed before with the multiple layers of filters and interpretation of data as it's passed along. And by doing this, you're able to avoid costly changes that are not going to address the root issue. So another way of looking at this principle is how it relates to the big data evolution. In today's data-driven world, it's not uncommon that many important business decisions are made based on data and reports. This data is stored, it's taken, it's processed using statistical methods, and conclusions are made based on the results of the analysis. But the question is this data itself reliable? In today's world and the need to be agile and make swift changes and rapid decisions, it's very easy to make these decisions based on data alone. But as Walters points out, if we focusing on the data itself, we're just separating ourselves from the true activities within the process. Toyota understood that it was not practical to have all their top executives spending all their time out on the floor, but they did not excuse them from knowing what was going on. So that to help resolve this issue, they developed Horinsu to keep leaders informed. And Horinsu is actually an amalgamation of 3 different words. Hokok, meaning to report, Renraku, to periodically provide updates, and Sudan, which means to advise. So what you needed were subordinates that had a firm grasp of the Genchi Genbutsu theory and applied it, and then they were trusted by leadership to provide accurate reports that were synthesized up to them so that they could, by proxy, have a good understanding of what is going on the factory floor and what issues they're seeing. Okay, so now we'll come to our first case study, which is based on my experience out in the manufacturing industry, and to provide a little bit of background on it. This is my first job out of college as an engineer working for a propeller company, and I was responsible for fixing defects that occurred during the manufacturing process, as well as facilitating drawing changes. For those of you not familiar with aviation or aircraft in general, the propeller is the spinning thing in front of the aircraft, which provides the thrust that allows it to fly. Okay, so for those of you not familiar with it, there are 2 basic types of propellers. You have the fixed pitch propellers, where the blades of the propeller do not change angle during flight. This is usually machined out of a single piece of forged metal, and the angle of the blades is set by that machining process and do not change. On the other hand, you have the constant speed propeller, where the angle of the blades are continuously changing to keep the RPM set at whatever setting the pilot has it at. These are usually made up of multiple parts that all come together to form that system. Okay, so how does this apply to Principle 12 and Genchi Genbutsu? So when I first started being a fresh engineer out of college, not having much experience in the industry, I went to my supervisor and asked him, if it would be possible for me to work out on the shop floor a little time each week in order to get a better understanding drawing of the different processes that go into making this product, as well as the product itself. And he agreed that it would be a great idea. So each week got to spend time out on the shop floor working alongside all the other shop workers. Got to see the CNC machining of the blades, the chemical processes, the anodizing of the blades and the hubs and all the parts. Got to see the final blade bending and shaping in order to get the proper profile and blade angles set, as well as the drilling and tapping of the fittings, all the way through to the final assembly that would be shipped out the door to the customer. So the benefits of applying Genchi Genbatsu in Principle 12 were abundant. I was able to receive a tremendous amount of knowledge of the product itself, learning the different types of propellers and how they're governed. And also going out on the shop floor each week, I was able to help kind of bridge the gap between the shop workers and the engineering department. And this really helped bring us closer together and work cohesively as a unit. As well as going out on the shop floor, I was also able to learn the different processes and to see the unique issues and problems that are faced at each of these different stations by the workers. And this really helped to understand the big picture of what's going on and what the shop floor is seeing. And by doing this, I was able to speak intelligently based on information that I had personally verified. This really helped because our design group was actually located in a different part of the country, so we would have to communicate back and forth, you know, what their new designs were or what their improvements were, and we could kind of discuss intelligently based on what I've seen, you know, what we're capable of and what issues we're currently seeing, so we can help avoid those in the future. So Genchi Genbatsu really helped benefit both the company as well as myself by learning a lot more about the product and processes, as well as making good business decisions.
My case study is a company where I worked during my internship as an automation engineer. It was a manufacturing plant which recycles aluminum and forms ingots of different sizes. So my job was to programming the programmable logic controllers for the automation of the process. So as an engineer, I thought that I would be just working on desk and programming, but the lead of the team put me on in the casting team, where I was surprised to know that. But as a casting, I worked in a casting team. Is it next time? So the three important things I learned was that I was able to learn the entire process, because I had to work on the shop floor where the casting teams to do the casting. So I knew about the entire process. How does it work? How is the automation for it? Also, I had clear objectives of designing and integrating the system, whatever my project was. And it also helped me to communicate with the casting team what their problems were, what the expectations were, and how they wanted the new system to be integrated with the current system. So this helped me a lot to overcome my barriers as well as the barriers faced by the organization to integrate the new system. So next time. So also there was an implementation of Horensu methodology where I saw in the company where all the decisions were made by the management and to change the system. So it was not possible for the vice president or the director of the company to go and see at every level. So he had some engineers who he trusted the most, the engineers who could get data for him and then talk to him that what's wrong with the process, how it should be improved, and well, the management used to believe in them, so which helped the organization to grow even further and to solve problems without even for all small problems the management did not go and see. So yes, so it bridges a gap between the engineers and the management to solve this issue. So the next case study would be given by Ms. Deep.
This case study, like the other two, is also from a personal experience, and it comes from my own personal experience. I was working with a German company. It was GE Westphalia, and we were selling these centrifuges. These are typically two types of equipment we sell. One is a vertical centrifuge, and another one is a horizontal centrifuge. It's called a decanter. It's a simple technology. It's a centrifuge, which means that it uses centrifugal force to separate liquids and liquids of various densities, or liquids and solids. Because whenever there is a density difference, we can separate using this. And these machines, though the technology is similar, are used in various kinds of applications. Like you use it for fat separation in dairy, edible oil manufacturing, in ETP, effluent treatment plants, in marine for cleaning out water from the oil, and in pharma applications. Next slide. So I was actually appointed as a sales engineer in an area where the company didn't have much of domain, or much of base. So my job was primarily to go and speak with customers about the products, and try to explain them what what products we offer and how we differ from others. But the problem in that was, there are various industries where I have to go, and various industries use different jargons for their own processes. And being new in the organization, it takes time for me to understand those. I was directly reporting to Vice President Sales. He always used to encourage me to directly go speak with the customers and try to explain them about your product, and ask them to explain their process to you. That way, what happens is, they know that you know the product, but you don't know the process. So they'll try to explain you. When someone asks them with curiosity and interest, they'll definitely try to spend some time on you and explain you the process. That way, I learned a lot. And one such application was, we were selling machines for cotton seed oil, where they press cotton seeds and extract oil out of it. And I was visiting a plant where I was giving a sales presentation for a centrifuge for one particular application. But after the presentation, I asked the general manager of the plant if I can go around and see the process. So he said that's totally fine. And when I went around and saw, there was a filter process being used for another application, which is like similar extraction process, similar separation process. And those filter presses are used in another process, like for effluent treatment as well, where we supply decanters for the same application. Like where filter presses are being used, we supply decanters. So I just got curious if we can supply decanters in this application as well. I tried to speak to the plant people. They said they were not aware that there is any technology other than filter presses. Then I speak to my manager who deals in edible oil. He said this particular process doesn't use decanters in any of their application. Then I got curious, like he's saying decanters are not used, but I've seen personally that filter presses are being used, which can be replaced by a decanter. I spoke to Vice President Sales. He said he came along with me to the plant, and we checked out what is actually happening. What we realized was the cotton seed specific to that region has higher fiber level. So because of that, there is an additional step of clarification or purification required, which is not typical in other areas. So this specific application was very specific to this particular location. So we collected a few samples of those liquids, and we sent to a lab centrifuge, and we processed it. We figured out that we can supply a decanter at this particular application. So that way we were able to supply it. And all this happened because I went there and personally checked it, and later my boss took the effort to come down and see what is happening. So normally when we speak about lean manufacturing principles and all these, we just don't think of anything other than manufacturing. But these are philosophies rather than specific applications. These can be applied in any other business forms as well. So this was one such example. And in the textbook, they have presented other examples like Ono circle, where in a production facility, you draw a circle, stand in there, watch the process for 5 minutes or some time of a day, wherein you just don't watch it, you actually try to analyze and understand it. Like, it's very simple, it's basic, but from an application point of view, when you stand idle from all the other things and focus only on the process, you'll try to figure out what is going on and what might go wrong and what is going wrong. And another example they have presented is during the design stage of Sienna. In 2004, they were designing Sienna for American market. Toyota was typically a South Asian car manufacturer, and the culture of using a car in South Asia is typically they use it for transportation within a city. They go from one place to another place within a city, and the maximum traveling time will be less than 2 hours. But the culture is completely different in Europe and America. Here we use cars to travel like for 8 hours, 10 hours, or more than that. So Toyota has to adapt, and mostly when they are designing a minivan, it is specific for those applications. They have to adapt the design according to the requirement. So the chief engineer in that process came. He hired a car and traveled around America and Canada to see what problems he faces when he's on a long drive, and he built a design around that. So now we have seen that Genchi Genbatsu is a really good tool, and it can be applied everywhere. Is it always true? I want to ask your opinion about that. Do you think there is any place where it might go wrong, or what can go wrong?
Maybe if a person, the process itself is good, obviously. Maybe if a person's not really understanding what they're seeing or not really familiar is the only thing I can think of, because, first-hand knowledge is hard to beat.
Yeah.
Under any circumstance, of course.
And it's also like one person has a typical mindset of viewing the process, then you need someone else to understand it,
Exactly.
and that is really true. And any other?
I think if you are in a battlefield in a war,
Okay.
it should not be a good spot to apply Genbutsu, because you can get shot.
Okay.
But in the end, you need to analyze what happened in the battle to improve combat techniques. So there's like a trade-off in that.
That's another good example. Anything else? Anyone else?
That battle would be like really old days battle, because nowadays it's not like that.
No, I'm talking about body to body
Yeah. Combat.
combat.
Oh, okay.
Not just in like drones and all that kind of
Okay.
stuff.
Any other views?
I think it's really a matter of perspective. For example, no worker and possibly no engineer ever wants a controller in the production facilities. I mean, he has a completely different perspective, and I bet he can optimize something, at least in the numbers. Make something cheaper, cut a little bit, but it might be at the end of the day a disaster for the company itself, because he has no idea on how much it damages the process, even though the figures, the numbers might look better after his optimization. So
That's another good view.
perspective is a really important point when seeing for yourself.
Okay, I'll give you a simple example. We have Kalpani and we have Dr. Faris. So Kalpani grades up papers, and Dr. Faris says, okay, I follow Genchi Genbatsu, so I need to check all the papers again. How will the frontline employees feel about it? They feel that they're not being taken into confidence by the managers. Never mind. So we have seen that even the top level management is not waived off from Genchi Genbatsu. So it's like at what levels, up to what level of management or what level of hierarchy you'll expect people to go and see the processes themselves. So it kind of hurts the motivation levels of employees. So when we are incorporating these techniques into our organization, we need to understand the working culture of the organization as well. And it's equally important. With this, we would like to conclude. Thank you. Any questions?
Yeah. What about your process? Did you sell many machines to the cotton seed people?
Yeah, we were able to the company was not really willing to buy it, and we said we sold a machine on trial basis. They said we'll try that for 6 months, and then if it's working, then we'll pay you. That worked, and we were able to sell 20 machines in that particular area.
Oh, yeah.
So that's
Because
good.
I know the filter presses in that type of production. That's the standard.
I'll show you. I have a video which I've taken when I've gone there. Yeah, it's playing. This was the filter press.
Yeah.
So I was very curious those days. Whatever technology I didn't know, I used to record and later try to understand it.
Yeah. That's been the standard for a long time.
Yes.
too.
So this was the sludge which we're actually trying to purify. He was explaining to me in my native language. Any more questions?
ask you guys a
Yeah.
question. To what extent do you think Genchi Gambutsu, or either the use of the practice or worker readiness to accept the practice, is influenced by national culture?
Yeah, it completely depends on that. A Japanese culture accepts it, whereas if you see American culture of individuality and all those things, people won't accept someone questioning your capability of working. So they don't like it. So it varies. Again, that's what I said. You need to understand the company's culture, and Toyota cannot apply the same principle in US right away. They have to understand the people and how they work and apply it accordingly.
That's when the Horatsu methodology comes in, where it's like contradictory to Genchi Genbutsu, but if you practice it in the right way, then it can be helpful, where the management trusts your engineers, and then the engineer trusts the workers. So it's a level developed, so you don't have to go and see for yourself. Well, the engineers can go because the management can't sometimes. So
Can you explain a little bit more about that method and how it's used?
the Horatsu methodology.
method? Yeah.
Yeah, it's like the engineers are like the designers of the system, and they give the designs to the workers, so the workers implement it in any industry, and the management takes a decision, and they communicate with the engineers, and they don't communicate with the workers because the workers are controlled by the engineers. So it forms like a hierarchy where the workers are doing their job, the engineers are controlling them, and the management is controlling the engineers. So if the management has complete control and trust over the engineers, then you don't need to go and talk to the workers. Like if he's not performing well, you can take inputs from the engineers itself.
It's like it's as simple as that they're blocking
That's
the
what you-
they're blocking the level of application up to certain hierarchy levels. Like only the first two levels will actually go and see for yourself. After that, they'll be reporting directly at regular intervals and advising the management on what to do. That's how it goes.
I have one.
Yeah.
One comment, maybe one comment. I remember that in marketing and in industrial design, when you're designing objects for people like products, there is a technique, and also it's a research method that is called ethnography. Genchi Genbutsu reminds me ethnography a lot. That was just one comment.
Like I completely agree with that. Like in sales and marketing, this is the most needed thing.
Yes.
When you're selling something and you don't know what the customer's expectations are, or where he's going to install it, and you don't know the site conditions, you can't code for it. So you have to go see where the thing is actually getting installed when you sell it, and try to understand the customer's needs better.
And also, you sometimes when you want to perform a market research, you use ethnography technique. You record that, for instance, a house, how people is living, and you are Kimberly Clark, the paper company, and you realize that you can sell diapers because people use diapers and they have babies, and because you record people, and recording people is another way of Genchi Genbutsu.
Yeah.
Good point.
That's it.
Thank you, team.
Okay.
Alright.
Thank you.
Hi, good afternoon, everyone. We're Team 8, myself, Jitu Joy, my teammate Abhishek, and our listeners are on she's not here. But you can see our presentation slides and everything. So what we're going to talk about is principle number 13, which is make decisions slowly by conscientious but implement it rapidly. In other words, it's called Nembuwashi in Japanese. So this is how we're going to go about it. Introduction and the second case study will be explained by myself. The first case study of needs will be explained by my teammate Abhishek. And the third case study, Locate Martin, and conclusion will be done by Veronica. So with that being said, let's get to the So most of us know what lean manufacturing is because we've been going on hearing about it for the past 2-3 weeks. So I'm going to skim through most of the other topics about it. So what exactly is lean manufacturing? Lean manufacturing is a process of elimination of waste, and those are 3 types of waste. You have the MODA, the manufacturing waste. There's the MORI waste as a result of overburden, and there is more waste due to the faulty distribution of work. So this is the Toyota production system, as all of you know. So there you have the first pillar, that's the just-in-time, and then your second pillar of built-in quality. So the first pillar of just-in-time, it talks about building the right things at the right time at the right amount. And the second built-in quality talks about the Kaizen event and the 5S and how you can implement all of this. So this is an ideal lean manufacturing system. So these are the 4 divisions of the 14 principles mentioned by LICO. So the last step, which I'm going to be talking about, of conscientious decision making, comes in the 4th one, which is continuously solving problems by prioritizing organizational learning. So Toyota always explains about conscientious decision making. For example, it's mentioned that, like has mentioned that in Toyota, how you arrive at a decision is just as important as the decision itself. And for example, if an employee who works in Toyota makes the wrong decision, but by choosing the right approach, the management will be fine with that. But the same is not going to be said if an employee gets the right decision and uses the shortcut approach. And definitely, conscientious decision making is a collaborative effort. For example, let's talk about an example where there was a pilot's development, and for this they had a room called the Obeya room, which is known as a big room. And this is where there was a cross-functional team. There was the chief engineers involved in this, and all of them get together and they discuss the problem. And what happens in this is that they can make faster decisions at the right time, because Nemawashi itself would take a large amount of time. But if you're having the right people in the right time, you can make decisions at a much quicker rate. So, and this is done through 5 steps. So the first step has already been explained by the previous team, that was Jinji Gempatsu, which talks about going there and finding out what the situation is all about. Then you have the 5 why process, where after each why you're trying to find out the root cause of the problem, so it's an iterative method. And then you have multiple approaches where you're going to look at different alternatives of the system. And then this consensus within the team. And the last one is visual mode of communication. Like for Toyota, they had the A3 report, which was based on the Deming cycle. And this is an example of the A3 report, which is based on the Deming cycle. So you have plan, do, check, and act. And before the planning itself, you have another process of the Jinji Gempatsu, so you can understand the situation is all about. And it's important that when you're having a consensual decision making, you're trying to go for a win-win situation rather than you win, I lose, or both of us lose situation, which is never there. So what is, like, for an example of win-win situation would be in 2002 in Toyota's plant of Arizona, there was a megastructure development happening nearby. So what they found out was that if the megastructure development was happening, it's going to affect the long-term water sustainability in the region. So instead of just saying and going up and saying no to the whole thing, they went about, spoke with the people, the government, and the people who were in charge of the project, and they came up with an alternative solution. So what the solution was, they're going to set aside 200 acres of land and build up a water conservation reservoir. So for every gallon they're going to use, they're going to put up another gallon in the reservoir. So, and the first case study would be explained by my teammate Abhishek.
Hello everyone. Let's talk about needs and how it works. It's a non-governmental organization. It's a non-profit organization founded by M.M. Chaudhary in 1998. It's situated in Jharkhand and the district Deoghar. It's in India. So what NEED does is it helps people and enhance their capability or skills so that they can help themselves. NEEDs never provide themselves with any direct support or like giving them something, a monetary help or anything. They just provide with them with their skill enhancement or maybe technical supports and free programs accessing to and related to health, reproductive health or livelihood and education. So these are the main 3 sectors of needs. That's health, that deals with maternal and child health. Education is about child and awareness about birthright and all. And this is livelihood change. So, in order to help the community of people, NEED started a project in a small community named Palojuri. There, they developed a program named Ultra Poverty Mission, under which they approached this theory of change, which is like theory of change is all about accomplishment of a long-term goal. It deals with what the outcome you want in the long term rather than a short, like immediate effect. So under this theory, needs they believe that poverty can only be eradicated from the states of Jharkhand and Bihar if it is like if the people of those community are intervened with collaboration, and all the three major sectors of needs can work with them, not for them, but with them as a team. So for that they came up with this approach. It's like problem identification and problem solution. The step starts with monitoring the decision environment so that they can plan to do the perfect thing according to the situation. For instance, if they are planning to dig a well and it's a rainy season, then they need to change the plan accordingly. Second is like defining the decision so that everyone and each and every individual of the team can understand what it's all about. Specific decision objectives, that to assign persons their role in the team, and then the proper diagnosis of the problem, that is 5 analysis, which would require a team collaboration to get alternative solutions, and they would like run pilot tests with each solutions and come up with the proper thing and implement those in the field. So let me explain these all processes with this story of change in 2013. She is Dina Tudu. She was under the Ultra Poverty Mission of Needs. This is about her, like she is still a widow having 3 children. At 2013 she was pregnant and her like per day income is less than 50 cents. So how needs help her and like helped her achieve her normal life is about this case study. So what NEED does is, the main mission of NEEDS was to set up a well-being of society, a complete happiness, a healthy society. Like it should be from the perspective of health, education, social life and everything. So for that, the problem that they detected was on a broader scale was poverty and frequent pregnancy. So the current situation, that immediate effect of that was malnourished baby and maternal deaths. So the probable causes that came up with was poor access, lack of availability, and this. And if you see this includes the 5i thing, because poor access to health. If you question it, why? It's because lack of awareness. Because the community people were not aware of the government facilities or presence of a nursing home or what is a nursing home, given that. And if you keep on asking them, you'll come across the lack of awareness is because of no money to feed the child, is no livelihood because they don't have money, they cannot afford education because the society is not educated. There is a social pressure to like for early child marriage and all, and just because they don't have money and livelihood, they are not ready to take responsibilities of their girl child especially, and that will result in the safety respect of the female child. So from there, the areas to intervene that all the 3 sectors of need came up with was mobilizing the community, the livelihood sector, education, health access, child protection, that is child line, and government. From there, all the teams they collaborated and came up with a plan. They proposed the budget to the top management, which was then approved and implemented to get the outcome. Outcome here is not the output, which is the immediate effect, but it's a long-term effect. So what they did was they set up an interdisciplinary team which consisted of health sector, education sector, child line. These 3 are the sector of within the system of needs. Then banks, government and panchayat are the external resources. Like they have nothing to do with needs, but they included them as well in the system. So starting with health sector, what they did was, their mission was to give awareness about nutrition and reproductive health. If a mother is pregnant, what foods is needed by her and what are the medications she should be given by the government for free. So they should be aware of that. Then comes education. Education sector deals with all the birthright, academics and entrepreneurship. Entrepreneurship here is leadership skills like building crafts or candles or something like that. And then comes the child protection line, which ensures that no potential child labor is being forced to do child labor or early marriages and all. And the banks for financial security and loan for the farmers. Government panchayat to help and collaborate with the decision making, so that at each and every step the community need not take permission from them because they are within the team now. And the main thing was the panchayat community, that is self-help group. self-help group was initiated by the members of the community itself. Like they used to train each other and develop organization among themselves and used to help each other in all these sectors. So in this way, it was like a collaborative effort within needs, a collaborative effort exterior to needs, and thus they could like develop a sustainable change to get the outcome rather than the output. And thus, Dina to do like it makes her happy. So this was all about needs. Now Jitu will explain his case study of Volvo. Thank you.
Okay, the second case study that I'll be talking about is Volvo Car Corporation, and I believe this is a company that doesn't really need much of an introduction. I mean, it's a company that gave us a seat belt. It's a company that gave us the two-stage airbags as well. So with that being said, Volvo Car Corporation was founded in 1927 in Sweden. It was later acquired by Ford Motor Company in 1999, and currently it's being held by the Geely Holding Group, which is based in China. So what Volvo does is it has around 400,000 cars which is being sold on a yearly basis, and success can be attributed to its core values, which is safety, quality, and for the environment and for its employees. So one of, like I previously talked about a win-win situation. So Volvo tries to have a win-win situation by decreasing the density of its cars so that 85% of the cars could be recycled. And it takes an active part in leading water conservation measures based on the footprint calculations. Now this is the Volvo production system. As you can see, it is pretty similar to the Toyota production system, where you have the built-in quality, just-in-time, continuous improvement, you have the Kaizen events, you have the 5S. And this is an unlike the Volvo way, where you have the leadership, safety, and the environmental care as a base. Now, the case study that I will be talking about was based on the thesis of, as per the Volvo PhD program, which is based in Sweden. So this is based on the conceptual decision making. And what is the conceptual decision making? It is part of the development division in Volvo, which has around 2,500 employees. So what they do is that they come up with several concept and alternative solutions, which can be, and out of that, only one of them will be selected in the final phase. So the case study that I'll be talking about is a spec case study, and this is one where, in retrospective, it didn't work out for the company, and they had to go back and revise, and there was a waste of resources as well. So now, one of the reasons why the concept solution didn't work out was it was an incremental decision-making approach, and it had a fragmented leaps approach. So when you have a decision-making in leaps and loops, what that means is, as a fragmented approach, there's a waste of resources, and you have to constantly revise. So you have to go back to square one and start again. So another reason why it failed was there was a design fixation and attachment to concepts, which made the design engineers stick to the initial idea itself. They weren't thinking outside the box. They were trying to solve as many problems with the initial plan they had, because they've been spending months trying to figure out one itself. So another fact that was found out, that employees higher up the hierarchy had a stepwise. This is product development first, but when you come down to the people who are directly involved in the project, they have an iterative approach, which means that they're doing based on the daily choices and small choices that they make on a daily basis. So one of the major issues that gave another conflict was when you had to choose between the reuse and an innovative solution, because the Volvo Corporation kept telling the employees kept encouraging them to find out potential for existing solutions. So when you have a conflict where you have to choose between new ones, and especially the fact that these new solutions have low maturity levels, so they haven't been tested in the field. But whereas when you have something that's already been tested, you know that's going to be successful. And this is the example of front-end activities that happens in the Volvo Corporation. So where you have identify the customer's needs, you generate concepts, you select the concepts, you test the concept, and only then would you select the one based on the product testing after that. So another problem that came across was an electronic template. An electronic template is where an alternative solution is being used by the systems leader. So how it works out is that for every department, you have a concept leader, you have a systems leader, and then you have a systems expert in charge of multiple projects being happening. So systems expert are the ones who take down the alternative solutions, its technical details. So what happened in the spec case study was that in the electronic template, it failed to carefully define the criteria to be evaluated. So what happened was the team members used their own interpretation for what should go down in this criteria. And that's about the spec case study and the reason why it failed. And another fact that I already mentioned was that in the Toyota they have something called as Obey, which is a big room. And something similar is there in the Toyota where you have the technical review meeting, which is the highest meeting of the technical team, and it also has a management So in such a team, what happens is you have the managers, you have the cross-disciplinary team all coming together to make decisions. And what helps in this decision making is a visual representation, which is being used in as a virtual series, as I mentioned. So you have a model representation of what is being happening. And what you can see is that in this technical review meeting, there were 4 questions which help to foster the decision-making process. So that is the elucidating questions. So what is elucidating questions is that it reassures the presenter about what they're presenting. And then you have the self-enlightening questions. Self-enlightening questions enhances the understanding of the presenter. And then you have the argumentative questions. Argumentative questions are the one that diminishes what the presenter is saying. So based on the spec case study that was done in Volvo Corporation in Sweden, he came up with a proposed decision-making model. And this proposed decision-making model talks about how you have seminars, how you coach the teams, how you coach people, and there's visualization of the content, then there's battery of questions, and this talks about how you have a set of events which helps to make a better decisions on a daily basis. So now the third case study about Lockheed Martin would be explained by the distance student.
Hi, my name is Veronica Scarborough, and I'm going to go over the third case illustration on Lockheed Martin. Lockheed Martin is a global security, aerospace, and information technology company comprised of 5 business units: aeronautics, information systems and global solutions, missiles and fire control, mission systems and training, and space systems. They're the world's largest defense contractor and known for their work with NASA, satellite systems, aircraft such as the F-35 Joint Strike Fighter, and missile defense systems. They had not been known for vehicles. However, a decision was made to change that. In 2004, Lockheed's Missiles and Fire Control business unit decided to enter the tactical wheeled vehicle market. While this decision seemed unexpected, this was a well-thought-out strategic plan. The U.S. Army's high-mobility multi-purpose wheeled vehicles, Humvees, were designed in the 1980s and not equipped to handle threats faced in Afghanistan in the early 2000s. While the vehicle is heavily armored, its low profile and flat bottom made it vulnerable to roadside bombs and IEDs. The U.S. military was going to need a replacement. The Joint Light Tactical Vehicle, JLTV, is the next-generation light armored vehicle for the armed services, aimed at replacing the aging fleet of Humvees. This business prospect is estimated to be worth $30 billion for the supply of nearly 50,000 vehicles to the Army and Marine Corps. The decision to design and build light tactical vehicles in an effort to win the JLTV contract followed Toyota's 13th management principle and much of its major elements. Genshi Genbutsu, Go and See, revolves around the principle that in order to truly understand a process, one must go to where the work is being performed. Lockheed representatives toured multiple facilities to gain greater understanding of vehicle manufacturing, including BAE Systems in Sealy, Texas, and HMT Vehicles in Bristol, United Kingdom. In 2004, Lockheed entered into a license agreement with HMT Vehicles and acquired the company in 2006. To be a strong competitor for the JLTV contract, Lockheed had to understand underlying causes for replacing the Humvee. Beyond the high-level thought, it's simply time for something new. By questioning and continuing to delve into root causes, Lockheed learned design constraints to avoid and needs the U.S. Army had that may not have specifically been on their technical requirements list for contract bidding. With ever-changing military needs and deployment locations, Lockheed incorporated flexibility and expandability into their design. A few examples of these enhancements are an engine compartment that can accommodate a variety of different engine options, kitted armor solution allowing for easy adjustments to protection, and an integrated starter generator with growth capacity to deliver anywhere from 15 kilowatts of power to 75, removing the need for supplemental power generation equipment. The process of Nimawashi is gathering support and feedback from all parties concerned for proposed change or project. With the JLTV program, a collaborative team was established to spearhead the design and prototyping. The team comprised of Lockheed Martin employees from various facilities, as well as partnered companies, including BAE Systems, Cummins Engine, Allison Transmissions, L3 Communications, and Mirador Defense. Each company on the team had a critical part in the design and manufacture of 22 prototype vehicles within 12 months of the engineering and manufacturing development phase in 2012. This achievement would not have been possible without team cohesion and design consensus. Lockheed has been leveraging lean techniques since the 1990s. The company's current system for process improvement is LM21, abbreviated for Lockheed Martin 21st Century. This enterprise excellence system is based on proven lean manufacturing and Six Sigma concepts and includes an 8-step process for improvements called the Path to Excellence, depicted on the right-hand side of this slide. Similar in concept to Toyota's A3 report, Lockheed utilizes a one-page format for efficient yet effective communication. The 4-blocker, shown on the bottom left of this slide, provides concise information on the process or metric involved in Block 1, the assessment in Block 2, the problem faced or opportunity for improvement in Block 3, and the improvement action to perform in Block 4. Lockheed successfully competed for the JLTV contract. A company with years of experience rooted in slow, iterative manufacturing of aircraft and space systems was able to attain the knowledge and capability to mass-produce vehicles. In August 2015, however, the U.S. Army awarded the JLTV contract to competitor Oshkosh. Toyota has a philosophy to forgive a decision that does not work as expected if the process used is the right one. Lockheed has a similar outlook. Although the contract loss was disappointing, it was communicated corporate-wide that everything was done correctly. The vehicles built were an achievement, and the team's efforts and corporate partnerships helped accomplish that feat. Venturing into a new market may not have been the right decision, but the right process was followed. Toyota has set a standard for lean practices in manufacturing. The Toyota production system is more than tools and techniques for implementing process improvements. It's a whole system, a company culture, and a way of doing business for all employees. The 14 principles of the Toyota Way established a framework for companies to follow to aid in the implementation and maintenance of lean systems. This presentation focused on the 13th principle of making decisions slowly, implementing rapidly. The principle stresses the importance of consensus in considering all possible causes and solutions before implementing a new design or change. Rapid implementation cannot be achieved without adequate planning. The case studies on Needs, Volvo, and Lockheed Martin provided insight on how other companies make decisions and compared their practices to the core elements of this principle. While each have their own processes and tools, they're all rooted in the same basic principles. A concluding thought from the Toyota Way is how you arrive at the decision is just as important as the quality of the decision.
So this was all about the case study. So any questions?
Question is about, you're talking about implementing rapidly. So when you implement the decision rapidly, so how do you going to standardize the work?
Sorry?
How do you going to standardize the work?
No, you're getting it wrong. It's actually, suppose you have a year's time to implement a project, right? And if you make a decision in the first month itself and then start implementing, you'll face problems throughout the 11 months, right? And if you take about 9 to 10 months to make the decision and you are like, you have sorted out all the problems within the decision making itself, then you can implement it rapidly. In that time you won't face difficulties. So decision making should be done, like should be given priority, then implementation will automatically be done in a short period of time.
So you are going to standardize the task during the decision making period, right?
Because during the decision making the check thing comes now.
Okay.
Plan, do, check and then implement.
from what I understand from your presentation, this principle is mainly applicable in projects rather than a production system. Is Toyota applying these in the R&D projects or actually on the shop floor? Because you have time to take a decision only on the projects, but on a shop floor you don't have time to take decisions. You have to take decisions instantaneously. So can you clarify on that?
On the book itself was mentioned that on the show floor they do try to implement it to some level, even though, like you said, you don't have as much time as you have when you're going for another place where you can actually take 9 months or 8 months. When you're coming with the new model, when you're coming with the Pyrus or the new Lexus, you have enough time. You have given 3-4 years, and then you can easily pace it out. Like if you do 2 years for planning and then 2 years another year for testing. So in the test floor, I mean in the actual floor, it's probably not you don't have that much time, but you do it to a certain degree.
Discussion of the positive effects of this process, the Principle 13, especially the Nemawashi aspects. Are there any potential negative sides to this principle, and if so, how might you try to combat those?
I think one of the negatives would be if you're sometimes you end up taking too much time in the decision-making process, and like when you keep analyzing the question, and you might end up taking more time, and you wouldn't get to find the right solution in the time frame. So it's always necessary that you have a team of people working together, and that once you have the 5 why process, you stop in the 5 why, and so you can understand the root cause of it. I think that would be one of the negatives that could be.
We could have a frequent implementation of checking. Like we should keep on checking at each stage, so that even after taking a consistent decision, like taking much time in decision making, we can ensure that while implementing we won't face any problems. Checking phase would be repeatedly be there.
All right, thank you guys.
Thank you, team.
Good evening, everyone. Today, our distinguished student Chris will start the presentation.
Please turn on the mic.
Good afternoon. My team's topic is Principle 14, Becoming a Learning Organization. My name is Chris. I'll be talking about learning organizations in general. Nitish will be talking about the Hansei principle, and Karan will be talking about Kaizen. As I mentioned before, my name is Chris, and I'll be talking about learning organizations in general. Now, learning organizations are something that's difficult to define because of various interpretations, but there's typically some commonality or common themes that you'll see in these definitions. In a more personal context, or to frame it a little bit more personally, most people have been part of learning organizations without really noticing it or labeling it that way. Example may be a study group or a sports team that's performing exceptionally well. And if you look back at the experience, you'll see a lot of common traits that reflect organizational behaviors that define what a learning organization is. These traits have common themes, so it's often like diet books where people claim to have a magic bullet, but if you look systemically, there's a lot of common themes that are rarely captured. In reality, there's no magic recipe for creating learning organizations. Personality profiles and cultural differences will always require an agile definition. The exact formula that works for Toyota won't work for the Avengers, but both can benefit from a mix of key concepts.
The book Good to Great had some really great examples of learning organizations and some of the traits and behaviors that we see. One of them that really stuck with me is World War II. Winston Churchill, he created a group called the Central Statistical Office, and their job was essentially to tell him the truth. And the quote right here is, he feared that his towering personality might deter bad news from reaching him. And that honesty and reflection is really, it's a trait that Winston Churchill recognized as required for him to succeed. So he created an organization that was set up specifically for that purpose. So there's a bunch of examples, but I'm going to focus on 3 real traits. The keys to a learning organization really fall around a system of feedback, honesty, and then tempering their view of their organization with reality. That's very important. If you want some more examples, Good to Great, I've already recommended the 5th discipline, which we'll read in another class. Also maybe the Oz principle. There's some examples of text that have great pieces of what makes a learning organization truly successful. The Toyota process, which we saw outlined in Leiker's book, we'll walk through some of the steps that they have. There are some key concepts that are mixed throughout, but starting out, we have an initial perception of the problem, and at this stage, it's really too big. It can cause damage if you try and fix it at this stage. So then you go down to clarifying the problem. Once you've identified it, you clarify it, narrow the scope so that it's something that's manageable, it's a little bit more attractable. After that, you go into a root cause analysis, and we'll delve a little bit more in depth into what this is, but the Toyota process involves 5 whys. They ask why 5 times to determine the root cause. We'll see that in an example coming up. After you've determined the root cause, you come up with a mitigation strategy, come up with countermeasures to take care of it, and then evaluate to make sure that those results are verified. Once you verify the results, you need to make sure that you implement the changes and standardize the process. So the scenario I'm going to use as an example of this process, we issued a software update, and the software update, there was an installation error. So the caller called in, said they had an installation error. When we delved a little deeper and clarified the problem, we determined it was a .NET installation error. They didn't have the required packages to install that software. So the 5 why analysis associated with that was the software couldn't be installed because of the .NET framework missing. But when we asked why, well, the IT update didn't push correctly to the computer. When we asked why, well, it failed to correctly install. Why? Because the user had a full hard drive. They couldn't physically install the device. Why? Because old manuals were being archived locally to save cost on bandwidth. So you can see the issue grew pretty substantially from the initial perception of what was going wrong. So in this case, the countermeasure was twofold: package installation and check for requirements to make sure that the software will deploy correctly, and then also have IT correct the installation errors. The software itself was made to fix the bandwidth issues, so just by doing that, we corrected the 5th issue. Then we evaluate the results, correct the issue, and make sure that the allowed installation happens. We also added a test case to make sure that this happens. This fixes the error and also fixes the future implementations of this error. And then you standardize. So implementing that correction into the procedure for distribution to make sure that this doesn't happen again, making sure that all of our software is checked to a standard to allow us to verify that this won't happen prior to release. With that, please allow us a couple seconds to switch over to Nitish, who's going to tell you a little bit about relentless reflection and Hansei.
Good evening, everyone. Today I'm going to speak about the relentless reflection, which is also called as a Hansei way. Hansi way. Hansi is a Japanese word which means like accepting your mistake and reflecting back and accepting your mistake. If you are like a Japanese child, your mother and father would ask sometimes if you did a bad thing, just do the Hansi way. It means like accept that you did something wrong and change your attitude. That's where the Hansi way came from. Most of the Japanese firms follows this Hansi way. They consider it as an important step for the next continuous improvement or continuous improvement process for regaining their product market value or anything. Firstly, it was even though Toyota started its operations in America way back, they did not introduce this Hansi way into the American production system because they thought it was like something alien word to the American. I can give you the good example for this. If a Japanese president or Japanese vice president goes and speaks to the design engineers after they design a prototype, they say that this design is bad. What the US employees feel it as like, we did so much work, so we should be get rewarding. Instead of place, he pointed out the mistakes. Whereas if it's the Japanese workers, they feel that they did something wrong and they have to improve that. So this was a cultural difference. So they thought it would be like some alien word, but at some point of time they should have introduced this word into the American market. So in 1994, Hansi was introduced into the Toyota way in the American market, into the American production system, and they call it as a reflection. Hansi is not only mean that it is a negative, like looking back into your mistakes. It also they have the Hansi meetings after every milestones. It means like looking back into their process and finding out their weakness so that they can work on their weakness and improve the process again and again. So it is not a negative, and Hansi is a base for the Kaizen. Without Hansi, Kaizen has no meaning or no sense. What I say. Sorry. And I want to speak about the Hoshin Kearney, which can be also like define the motivation and taking your goals to the lower level workers. The problem with the workers is like problem with the organization. The organization fixes the goals and targets. They fix their objectives. They fix their visions. But the main step they forgot is like they need to take their goals and organization to lower level employees. They need to break down their goals and be specific to the lower level organizations. That way, Toyota did that into the four. If you look at this diagram, first the organization sets the targets of the time, quality, cost, and innovation. And the work of the executive staff is to cut down those targets and take into the manager supervisor to define what they have to improve specifically and what are the time specifications and what are the specific targets they have to. They have the executive staff have break down that for the managers and supervisors, and the next task is that supervisors and managers break down that task for the working teams, like what exact action of plan they have to follow and what exact target they have to do and what are the countermeasures they have to do in order to achieve the main goal. So this is how the goals are break down and took into the lower level work organizations. And after everything, they have like checking with everything. They have they do the Hansi way. Like they go into everything, they find out what the mistake and they do the countermeasures. One good example for this one, Toyota. If you once author visited the Toyota plant in Kentucky, and there was a matrices and charts all over the lab floor, all over the floor, and these in this matrix, it was in 2000. They defined targets for the next 3 years, like they have to reduce the packing cost by 47%, they have to reduce the inventory by 50%. These are the specific tasks for the next 3 years. And down the matrix there was like a color coded where it's like if you achieve the target by more than less than 50%, you should mark it up by red. If it by 50 to 89%, you should mark it by yellow. And if you achieve more than 90% of the target, you should mark it by the green. So although we visited this plant in 2002, which is after almost 2 years after the setting the goals, and what you observe, like they almost reached their goals within the very less time of their target. This is only possible because of this relentless repetition enhancing query. Due to the high level management cut down their goals and mention the specific targets to each and every, and they did a continuous checking on them whether they are achieving the targets and what are the measures they have to take. So this is the main base for achieving it. Sorry, this is a PDCA cycle, which other team also said. This is like creating the flow first, next do the surface plan, and then do the countermeasures, and then evaluate to check whether what's going on wrong, and the cycle goes on again and again. This is to eliminate the waste. And my case study on the Hansi way, I would like to give the example of the Domino's. Domino's started in 1960s, but where it popularized is like it delivered the pizza within the 30 minutes, if you call them. This was a main revolutionary idea, which it gave the succeed to it in the market. What I think. It was going on very well until the 2010, where the other competitors rise up, like Pizza Hut, everything going rise up, and the customer satisfaction went down. And the reason for this, when the company CEO, at present CEO, find out the customer comments, one of the comments like their pizza tastes worse, because like in order to deliver the pizza in 30 minutes, they mostly depend upon the frozen crust and frozen sauce which is ready to do and deliver it in 30 minutes. So there it went wrong. So the CEO of the company did the Hansi way, like he conducted a review meeting with all his staff and see what's going on wrong with his company. So they saw that what's going on wrong with the product, and the wrong was like the taste of it. So they tried different sauces, half dozen of sauces and half dozen of crust, different sauce and different crust, and they spent millions on that. And they tried their new taste of pizza on 1,800 people blindfoldedly, because they didn't tell that they changed it, but they changed it. After that, they made this strategic planning, like they released an advertisement into the market saying that yes, we did something wrong. The way our pizzas were tasted worse way back, but we changed it. Our pizzas tasted good. So this gave them a very good pushback. And guess what? There was like 14.3 increase in the revenue and like 400% increase in the stock value. This is only because of they admitted that they did wrong and they did the countermeasures, and they again raise up to the market. Right now, it's customer satisfaction increased from 69% to 91% in the American market. And the next thing, Karan will go on.
Good afternoon all. I'm going to present the last part of this principle. It's Kaizen. Dr. Jennifer has presented a typical Kaizen event in the last lecture, and I would like to elaborate it. So Kaizen is a Japanese term basically. Kai means a change and Gen means a good. So it's a change for the better or the continuous process improvement. Kaizen was originally come from West by the Masaki Imai, who is Masaki Imai is a Japanese organizational theorist and management consultant. He implemented it in his first book, Kaizen, the Key to Japan's Competitive Success, in 1986. So today, the Kaizen is recognized worldwide as an important pillar of organizations' long-term strategic planning. So let's talk about the methodology of the Kaizen. It's also called the practical problem-solving methodologies. So Kaizen as a methodology has an ability to speed up the change process and most importantly, standardize the solutions into the best way. So there are 10 steps which Kaizen follows. The first one is define the problems. Trainers at Toyota who teach this methodology within the Toyota has found that the most important part is to learn how to reach the actual problem, the grasping of the situation. So the next part is document the current situation. So after identifying the actual problem, go to the current situation and followed by the desired future state with the help of bilateral mapping. Then brainstorming is normally done by the cross-functional team incorporated with different kind of people, such as few frontline workers, engineers, managers, co-workers, and suppliers, etc. They sat together and set the targets, primary targets, which are going to remarkably impact to the productivity and quality of the firm. Various methods are used, such as spaghetti diagram, fishbone diagram, 5 Ys or 5S, which are used to find the root cause of the problem, and eventually justify the results with the previous one and document the prepared summary. And all in all, Kaizen can only occur when the process is stable and standardized. So the total preventive maintenance is a must. Now I'm going to explain the case-based example on lean thinking. It's a transformation to lean manufacturing by an automobile component manufacturing company in India. So this company primarily manufacturing drag links, center links, and tie rods for India's major car manufacturing companies. The typical operations involved for making tubes are heating, spacing single, and double bending processes. In order to achieve the improved market share and compete with the global counterparts, the automotive component manufacturing companies in India necessarily need to improve the productivity while ensuring the lower cost and world-class quality. So in the recent years, this company has tried many options with the huge capital investment. However, the results achieved were not significant compared to the investment made. So in the striving towards consistency, this company, the management actually decided to implement the Kaizen tool. So you can see from the table that the nature of the process is batch production, and so that the setup time and the WIP is pretty much higher, and so as material travel distance. So the scenario is poor quality and productivity for that time in the company. So tools, techniques, and metrics aside, the Toyota's greatest emphasis is on thinking through problems and solutions. So at Toyota, it is said that only the 20% of part they involve in problem solving, and remaining 80% is on thinking. This company followed the same path as Toyota did. They first arranged the brainstorming session in which they incorporated all the employees from CEO to even workers, and they all are allowed to give any key suggestions regarding improvements. After few brainstorming processes and comprehensive study of the shop floor, it was found that the tube subassembly line consists various forms of non-value-added activities, such as high build-up inventories, high lead times, unnecessary material flow, and high material travel distances. So, in order to implement this lean tool, they finally decided to form a team which consists of a different department, such as the planning, scheduling, sequencing, and production department, and all have a wealthy and a profound knowledge of all activities. They set the three major objectives to reduce the level of the non-value-added activities. The first one is fostering the line productivity by 25%, reducing the changeover time to only 10 minutes, and also reducing the WIP to 200 from 2,000 and 200 minutes units. Sorry. Initially, they prepared a current value stream map. So here the plant is working 8 hours per day. So the total process time for a unit is 2.8 days. So it's around 80,604 seconds. However, the value-added activity is only 1 hour 101 seconds. So it's less than 1 second. So it's time to improvement. The only focus is on the changeover time for every process. So in order to reduce the changeover time, different strategies such as data documentation, time and method analysis, review of a standardized process, and continuous monitoring of a process have adopted. The first bar chart you can see here, the setup time for banding process has marginally contributed to the total changeover time, and this second one is the changeover time reduction methodology. So to learn means having the capacity to build on your past and proceed incrementally. This is the Toyota's philosophy. And the company did exactly the same thing. So instead of relying on the previous monotonous and time-consuming method, team identified the root cause and developed countermeasures for banding process. And this is called real learning organization. From various analysis and methods, the team choose Pareto analysis because in this type of situation it's more appropriate. So Pareto analysis is used to prioritize and sort out the problems according to severity, frequency, nature, or sources. You can see from the table that there are 28 activities, and total 28 activities, only 9 activities are evaluated, and all 19 activities are non-evaluated activities. So they prepared a Pareto analysis in which it involves 19 non-evaluated activities versus the respective total processing time. So finally, the all focus is on the reducing the banding, reduce the changeover time for all processes, and especially for banding process. So the special kind of Kaizen team was established to look over the changeover time reduction, and in this step, the facts of the processes and the improvement methods are examined. The Kaizen team has designed and processed concepts and simulate it and implement it unless the optimum solution was found. And finally, they found the 2 alternate methods for improvement with the help of 13 based Kaizen ideas. These 2 methods, and the first one is the standardization height of the beam, and the second one is the locator of the tube. So you can see from the picture that before the Kaizen has implemented, they map in the vertical direction, and after that they used to do in the horizontal direction. They invented a new improved offset checking method, and using Arena they simulated the whole production system after a while, and it would be like 73% of reduction. And at last but not in the least, they have completed 2 major goals. The first one is more than 25% of productivity improvements, and the WIP, the inventory, is reduced to the 200 units. And while also the reduction of changeover time has marginally reduced by huge percentage. You can see here the picture of Mario. I thought this would be a good example of continuous improving on a brand or a product and reinventing yourself along the way. Thank you. If you have a question.
How much do you think, I guess, the becoming a learning organization depends on the culture of either the organization itself or the country in which the organization is located?
Okay, as I said earlier, the Toyota, even though launched its operations in America way back, it didn't introduce the Hansi Way until the 1994. It's because of the cultural difference. But they thought it is a time to introduce the Hansi Way because, but they changed you need to understand the organization, you need to understand the culture of the people before implementing anything, because you don't want to be like introduce something and it's into the and the culture takes a different way and the organization is totally down. So they study the they study the culture, and they took their time, and they introduced it not as Hansi way, it as a relentless reflection, which is Hansi way, but it's not as exactly Hansi way. They named it as a review meetings or kickoff. It's not kickoff. It's a review meetings or reflection meetings, where the one weakness of the projects, or what are the downfalls they face during the project, or what are the difficulties they faced in the project, they all discussed, even the project is success or a loss, so that they know what are the weaknesses in them, what are the downsizes in doing the project, so that they can improve the process or product for the next time. So I think culture plays an important role, but in order to improve the organization, you need to cope up with the culture. You need to take your time and next improve the organization, introduce something into the organization. So that way it goes up in a positive way, not the negative.
Thank you, team.
Thank you, everyone.
So you can actually carpenter from this.
All right, so thank you, teams, for another set of very interesting presentations, and thank you to all the teams that have presented. It was very interesting to see all the examples and illustrations that you came up with and the different methods of delivering. So we are going to go ahead and take a break now. We'll take about a 5-minute break, so we'll regroup around 5:05. We'll talk more about Project 2 and the schedule for that. And then we will also do the lean demonstration, lean exercises. So about 5-minute break, and then we'll regroup.
Ich komme in 10 Minuten noch mal, vielleicht schieben wir das nicht mehr.
Oh, yes. So if you say that direction, then you can close down. Yeah.
I have to do
Yeah. So if you're just summarizing the article, I think the article is, summarize the article. You don't actually have to insert a constant, but they give you those things you summarize. You do have, you're right there. That's
doch zu sehen, auch was hier so, das was ich zum Beispiel gar nicht umschreiben kann. An den letzten Teil, weil sie die nicht umschreibt, sondern ja genau. Ja, der steht hier.
Now it's just says that there's tying. I think there is some tying. There should be some tying.
Possible, ja, mit ein paar Ebenen. Aber auch ein paar glaube ich. So wie es aussieht.
You're looking on the poster, right?
The purpose with
Yeah.
I haven't heard anything.
Actually,
how to coordinate them, but I just don't have an idea. I don't know more personal experience.
Yes, I think just right. So yeah, you're right. Your systems look a little bit different, but just I guess you it may not be.
So
Yes, maybe like it tests. We actually would like to see
It's hard to
research paper has done on to all the stock which are yeah.
But that was the only thing I found.
The only thing is, I think it's a research institute or something.
Yeah, that's true. Yeah, it wasn't as bad earlier, and then it started raining again. So it was raining in the morning, and then it
What you have to do in the spreadsheet? Oh, the assignment.
just said that he's not
and about like based on the leadership on the company expansion and the culture organization. Yeah,
मेरी तो आज last separate is.
So I think we can work there.
And so yeah,
Das hat mich verwirrt. Wird das jetzt zwei Zahlen oder?
क्या आ रहा है उसमें?
So after that, when the world found that Japan has increased so much, then also. After the US also started.
Yeah, irrelevant organization basics like
primary consultant
resistance.
And after those years, basically all the research paper have been worked on.
Yeah.
So I was just going to.
I wrote something about that. I wrote something about that. And one Just basic research.
Yeah, it was companies just description for
I mean, it is the basic principle of sales. Unless and until you go and see, you can, mostly in B2B sales. Business to
I like the concept of sales. Because, I mean, if you sell more than is needed,
the supply chain, In most of the cases, see, sales is the starting point of the whole operation, but sales is never involved in, never considered a part of supply chain.
Yeah, when I was working in a petrochemical company in the south part of Mexico, the headquarters was in Mexico City, but I was close to the oil, the oil fields and all that stuff. Mexico. And the salesmen, they were in Mexico City, they used all the plant just to ask if we have product. That was the only thing. I mean, do we have product? And we said no. Well, are we going to have that amount of product in a couple of days? Yes. All right. No. How long will it take? That's okay.
And most
all right, we'll go ahead and get started back, everybody. How's everybody doing after the break? Good. All right, so the next thing I wanted to do is talk briefly about Project 2. So Project 2 is due next Wednesday evening. We'll start the presentations on Thursday. So Project 2, we're focusing now on, so far we've been focusing more on the practical implications of Lean, and of course Leifer's book, where we have the principles outlined. Also, I know a lot of people found published case studies online as part of their illustrations. Now we're focusing more on some of the well, I guess we obviously call that theory, but some of the even more recent research and theoretical developments on both Deming's philosophy, total quality management, which comes from Deming's teaching, and also Lean. So we'll have those presentations. In terms of the schedule, since on this last day, October 29th, we're also going to be starting hopefully the Six Sigma material. We're I've kind of tried to front load the presentation, so we're going to have an aim to do 5 student presentations or team presentations per day. Theoretically, we should be able to do that given the time in class. If for some reason we run long because of some setbacks, either in technical difficulties or other setbacks, the team 5 can be a little bit flexible in terms of the presentation day. Hopefully, I don't think we'll have any problem having presentations on the assigned day. So we'll have, well, it's not team 5, it's actually team 1 with the 5th team to go on the day. So in the first day next week, October 15th, we'll have teams 10, 8, 12, 5, and 1 presenting in that order, and that's going to be the majority of articles on Deming's philosophy. After that, the next day, October 22nd, we'll have Team 11, Team 4, Team 6, Team 3, and Team 2. And then on the last day, we'll have Teams 7 and 9 presenting, and then we'll also start the Six Sigma material that day. So in terms of Project 2, one question I've got is about citation. So, how do I cite the article, or should I cite the article that I'm reviewing? So your focus here is on reviewing an article, providing a summary, also noting the connection to Leifer and Deming, and noting the limitations and opportunities for further advancement. So you do, of course, need to include the article in your reference list as a reference. Since you'll be summarizing a lot of material from the article, typically when you would take an idea from a published source, even if it's a summarization of an idea, typically you would use an in-text citation after you summarize that idea. But given the fact you're going to be summarizing a lot of ideas from the article, as long as you don't include direct, when you do include a direct quotation, that needs to be marked as a quotation. Use quotation marks to offset that. Do have a citation with the page number, but if you're just summarizing material from the article elsewhere, you don't have to do a citation every time you summarize something from the article, since it's going to be implied that you're, again, summarizing that article. But if you do use a direct quotation, use the regular direct quotation format, so quotation marks, and then also include a page number. Another thought is about trying to connect the what you're reading or what's in your article to Leiker and Deming. So sometimes you may have to, I guess, stretch a little bit in terms of if you don't see a connection there. Part of it may be, outlining how what you're seeing in your article is different, if at all, from what's prescribed by the philosophies of Deming and Leiker, as far as what Leiker has identified as the 14 principles of lean, and maybe what your article discusses lean to consist of, or what Deming has suggested of as his management philosophy in terms of his 14 principles, and also his theory of profound knowledge. If there's anything in your article that contradicts those, it might actually be kind of a more negative relationship. Or sometimes you may have to take a higher level view about how, for instance, Leiker's philosophy on learning and knowledge creation and Deming's philosophy on learning and knowledge creation relates to your article's philosophy on that. Another question I got was about what a limitation is. So a limitation really is just anything that potentially restricts the applicability and or validity of the study findings. So this may be something that was a result of a deliberate action by the authors. So for instance, let's say because of convenience, ability to get data for their sample, they chose to include only companies from a certain industry. Their interest was maybe actually beyond that industry, but they chose only a certain industry because they had connections to that industry to get data, or they at first chose to study maybe only a certain aspect of the lean philosophy, only a certain set of lean methods and tools instead of other potential lean tools, so that could be an example of a limitation. So again, by not taking this broader view, it could potentially impact the study results. So you want to discuss in your response, why you identify this as a limitation, why you think that it may impact the study results, and how you think it may impact the study results, and also why the authors allow that limitation. Also having a small sample size. Sometimes you don't get the sample size that you want originally, so that could be another example of a limitation. Other types of, so these would be, a lot of times the ones I've talked about so far would be more deliberate limitations. It's things that the authors knew about and chose to allow for whatever reason. But there's also limitations that occur because of either an error of the authors or an admission that maybe they don't realize about, or something you view as a potential error, right? Or if, for instance, if you have questions about their conclusions from their statistical analysis, whether they've interpreted the results correctly, or whether or not they've interpreted a concept correctly, that would be more of a limitation that may not come out of a deliberate choice for the author. So you can choose either of these limitations, either or a combination of both. Just make sure you describe, why did you identify it as a limitation? What are the potential implications on the study findings? And if you know why, if you know the authors chose to allow it, why do you think the authors either allowed the limitation or made this potential error? So I think those are all the questions I've received so far. Anybody else have any questions about the project or any? Yes.
Yeah, it's broken into 3 areas. I noticed for your team members, one linking to the terms in Leiker, and the first one is like factoring or something like that. Some team members are not understanding the first part. What's the phrase again? How's it exactly?
Which one?
phrased?
Which one what part are you talking about?
Let me see.
So an overview of the purpose of the paper, the methodology and findings.
Right.
So that's the paper overview.
Okay.
And then indicate how the paper relates to the work of Deming and Leiker. So really, what are the connections there? Again, is it more kind of a connection to their teaching about specific methods and tool, or is it more of a connection to some of their overarching philosophy, perhaps? And then the limitations.
Yeah.
And then, so you don't have to cite additional sources. It's just if, for instance, you find a source that supports this as a limitation, you could cite that. But you don't have to. You can also use logical arguments. And then opportunities for future extensions to the research should be, if you're thinking about, if you are these authors, or you are wanting to take what they did and extend it into a study for a dissertation or perhaps for your master's thesis, what would be the next step in this? So it's just a general description of what could be studied next for that.
Okay. Thank you.
So which part were you saying? People are not understanding the limitations?
Yeah, some.
Or the.
Some individuals they're reading other things into it.
Okay.
I'll explain.
Okay. And there's probably some room for interpretation on some of these things, as most. Any other questions? All right. Well, if anything else comes up between now and Wednesday, please do email Kalpani or I questions. Also, we will try to get the graded project 1 back to your teams, probably not too much before the due date. It's probably going to be more like Monday or Tuesday at this point, but at least so you'll have maybe a little bit of time to look over feedback from project 1 and make any last adjustments on it if you want to do that based on that. So the one exercise I wanted to do today, so we've been kind of pulling out some exercises that are commonly used for teaching lean in industry settings and helping us learn some of the more lean practices. Obviously, they relate as well to the principles. The one I wanted to highlight today is a standard work exercise or standard work training tool. So has anybody done an exercise before called the standard pig? Has anybody done that before? Okay, so we're going to do an illustration of standard work called the standard pig. So before we get into the simulation or get into the weeds of what we need, again, kind of my standard work reminder there, let's just go ahead and jump into the simulation. So you all should have been provided a blank sheet of paper. So what I want you to do right now is take probably about 5 minutes or so and draw a pig on your paper. So your only task is draw a pig. And then once you're done with your pig, you can pass it down to the end of the row and we'll have
How big?
just a pig. A pig. So a pig meaning a pig from which pork comes.
Okay.
Yeah. A pig, oink oink.
You have a name on this important paper?
Actually, yeah, you can write your name. You can name your pig. I think actually the training material suggests that you name your pig, so you might want to do that.
I gotta get rid of it. Promise not to laugh about it.
I'm sure it'll be wonderful. Fine. Finish with your pig. Thank you. Yeah, it's called bacon. That's a good name. Thank you. Yeah. So whenever you're done with your pigs, do it.
I thought it was smaller. Save some space for whenever.
Is that right?
It's bent. No, it's just oh, it should be.
Your best pet's one that does it.
That's your most easy pet, right?
Exactly.
Easily,
Well, they got those fake goldfish.
oh no, you can't. Yeah.
They're delicious.
You can also choose to be anonymous if you prefer not to write your name on your pig. You might want to claim that this could be worth money someday.
Yeah, obviously. I have fake goldfish at Walmart.
They have fake goldfish at Walmart?
They're pretty cool.
So do you want to experience a pet? You seriously talk about the
It's just the pump circulates and they float around in the water. And they're pretty cool.
You don't have to feed them. You have to worry about them dying because they die pretty easily. So.
You have to worry about nothing. No cat is going to want to dig them out and eat them.
Right. That's true.
If the electricity goes out, it'll be okay.
It's true, yeah. So a lot of advantages.
There's an awful lot.
Yeah.
Awful. And they look good.
Exactly.
They're not ugly, they're pretty good.
Well, that's good. So they're lifelike and pretty. They're not sickly goldfish.
Technology is there.
I wouldn't have a bad face.
Yeah, exactly.
You cheated.
You cheated.
Oh, we're using Google. Oh my. Let's see. So look at pigs. All right, anybody else have any pigs? All right, so we'll display our artwork here.
Oh, phenomenal.
Mine, I'm sure, would be the worst one. So pig eggs, bacon, Hans, I guess it's the pig's bend.
Yeah, it's not
Hans,
focusing.
I think it's not focused. Oh.
The previous one wasn't focused.
Okay. So this one is not. So Ben the pig. Anonymous pig. So I got a nice little heart on its tail. I like that. I am piglet.
It's not.
I guess I'm moving too
There you
quickly.
go.
Okay, I'll need to wait until it's actually showing.
It can't keep up with its artwork.
Piggy, which I think is a Lord of the Flies. Rock. That's cute. Pooh.
What a happy
He is a happy pig. Shaggy's a little more like a pig. Sadway's pig, right? You're pig after yourself. All right. Matt's. And then we have, Mr. Delicious. Probably a good name for a pig there. Mr. Delicious. And then finally we have
Nigger.
Not that. All right, so we have a name for you have a last pig there. So what did we notice about our pigs?
There's no standardization.
Yeah. So why do you think our pigs were so different?
Because each one of us have a different view of pigs.
Different skills and different types of pigs in different countries. Every country has like different
maybe countries have slightly different pigs. Yes.
Lack of requirements of instructions of specification of is required.
Okay, so there wasn't any indication of what was required as far as what type of pig. For instance, I know you were asking how large, and I wouldn't tell you, right? But I wouldn't tell you. Yeah.
There are different capabilities of drawing a pig.
Okay, so we have different natural artistic capabilities, right? Some people felt more comfortable drawing because maybe they like to sketch and draw anyway. Some people were not as comfortable trying to draw a pig. I think we had some people using Google as an NA for their pig artistry. So different skill levels, lack of specifications or requirements, different conceptualizations. That's a good point of what a pig looks like. And there are some genetic differences between different breeds of pigs, for instance, in different countries that are very common, but also just our mental model of what a pig is. If we think about a pig, do we think the cute little, cartoon pig like Porky Pig, or do we think a real pig, for instance? So we had all of these different ideas. Well, so what do we think would have helped us draw a more consistent pig?
A live pig here in the class.
Okay, so one would be a live pig, right? An example.
Yes.
Some more specifications around what we need to do. For instance,
a standard operating procedure.
A standard operating procedure. So if we had a standard operating procedure, we think we could draw a more consistent pig. So that is actually what we're going to do.
We can also have a tool, like a template to draw over it, or use like a model.
A template? Yeah, that actually would be probably the most extreme example for making sure we're exactly the same, is to have a template that is the same, right? So a template that we have that we can basically use for tracing the shape of the pig. Yes?
I can use a grid.
We can use a grid. So we can use a grid as well. So, and we have that as well. So you, if you look at what you've been given so far, so one of the ideas behind the tool of, the focus of Principle 6, which focuses on work standardization, the tool of standard work is coming up with a standard operating procedure that reflects the one best way of doing the work. And also, like you said, having a grid that can help visually guide the work. So you've been given a grid that looks like this. Looks like this, and then you've also been given the standard operating procedure. So take, and those I guess that are those that are off campus also can use both of these pieces of information. If you can focus here on this, I guess, and see if you can now draw your pig. So everybody drawing the pig using your grid and your standard operating procedure. Yes.
You don't have.
You don't have it yet? Okay. You don't have. You just have blank pages? Okay.
Oh, method is just for me.
So with teammates. Nee, muss die dann
Genau.
Wo ist die Taschenwäsche?
I'm suffering some issues with my handicap here.
Oh, that's true. You might need, so I guess it's called a combination with your thumb.
Yes. I never realized the thumb was so important.
It is pretty important to writing, that's for sure.
For everything.
Yeah.
थोड़ा देखते हो थोड़ा नहीं बना आँख नहीं है करते हो Yes. कौन सा हॉरिजॉन्टल नहीं बोला तूने ऐसा कैसे बोला उसने देख के एक्चुअली वो गलत है ऐसा आर्क होना चाहिए ड्रॉ एन आर्क
Oh, is it?
Yes, this one. With this instructions, it was easy. Yes.
That's yours, I guess you're done, right? You guys both done? It's pretty easy to follow.
Yes.
It's almost same. What we do.
सबसे पहले मेरा ये ट्यूसडे को किसका है किसी का तो है पक्का है
Still working on our pigs. Done?
नादिर का थर्सडे सुबह फ्राइडे
पिछली बार छोड़ दिया
तो ये तो देखा
अरे ये के मैन्युफैक्चरिंग जो सब्जेक्ट पढ़ा वो क्वेश्चन पूछा तो ही
क्या जाएगी तो
A couple more minutes and finish up the pigs as best we're able.
Need a few pig test runs.
We probably do, you know, it is a lot of pressure. So, thank you. Got some quality checks going on here. Thanks. Any other pigs? Thank you. All right, so we've got our standard work procedure, right? We have our standard operating procedure. We had the grid. So we had both of these, the actual work procedure and the grid. So now both of all of our pictures should look exactly the same, right?
Reasonably so.
Reasonably so. All right, let's see if they do. Here's our first one. Here's our second one. Definitely kind of similar, right? That one is just, I think, my fault, upside down. Here's our third one. And here's our fourth. This one is kind of cute. It's like a chinchilla. Kind of reminds me of the back a little bit. And then Higley. Het. Molly. Hopefully you're not naming this after a family member.
We're all reasonably uniform.
Yeah, so we notice. Get our non-conformist bag. So yeah, so we do notice a lot more similarity, right? So even though we did have a few that looked different, we didn't have each pig being, exactly identical. There was quite a bit of similarity between the pigs. So what, I guess, prevented the pigs from being even more similar? When we think about standard work, so we had one important element of standard work, right? We had the standard operating procedure. We did have a grid, which is one template for doing our work. Was there anything else that would have been more useful for us in terms of producing unit?
Starting point and the ending point of the line should be mentioned.
Okay, so yes, if you had maybe more, a little bit more detailed procedure or a little more clarity about what the starting point is.
Coordinate points or something.
So coordinate points, if you actually maybe had some visual cues, for instance, that would tell us more information about how we're supposed to draw the pig. So one of the typical things with the standard work is you won't just have the verbal description of the task. You'll also have some pictures for what the end product quality looks like, also for what in-process quality looks like, and what for the work layout should look like. So the thing that was missing initially here, go on? Training, yeah, and also training. So yeah, we missed that training element, so I guess we can kind of consider that first run a little bit of training. We also didn't have any sort of training. So even in the training stage, we typically would have our written procedure, our job aids, and then also some visual aids. I mean, our job aid, I guess we can consider a form of visual aid, but some visual aids as well. So if you look at what you've been given now for the next stage, see if now we can still do the same task, try to draw the pig with now we're using our procedure and that we have. So we're still using our procedure, but we also now have this nice visual guide as well. Listen to you.
We don't have the visual.
We're going to have
Grid sheet. Excuse me. No. Grid sheet.
Do you not have one? Okay.
The sheets.
This one? Bacon, yeah. Still making number 2, right?
Version 2.0.
Yeah, exactly. 2.0.
Okay.
Thank you.
That weight is back. She might be in the air.
Much more acceptable looking batch of pigs these days.
Yeah, I think we're going to end up with a more sensible looking batch of pigs. Do people still working on their pigs? Anybody still drawing their pigs? So we've got, thank you. Got some creative naming going on here. Okay, so here's our pigs. Okay, so Sir Pigglestone is a high-class pig. Bacon, version 2.0. Nameless pig that looks very happy. I am perfect. Pooh. So Pooh probably version 3.0. Oh no. Okay. And then we have second production run, quite clever. This pig. Oh, that was my fault. I just got a couple of them turned around. This one. This one. Hans. Version 2.0. The lean pig. Daisy. It's a cute name. This pig. And then we have this one. So we noticed that if you look at all these pigs, they are, for the most part, a lot more similar to each other. They also all look pretty similar to this visual design, which is our visual. So what we see from the standard work exercise is that even though as engineers, a lot of times we think the written procedures are enough, right? We think, I mean, first of all, it does underscore the need for some standard work procedure because when we saw in the first round, there was no standardization. It was chaos, right? It was kind of fun because everybody's pigs were kind of cute and they looked different and they were interesting. But if we do want a standard output that everybody's producing the same output each time as in a typical production process, would not be an acceptable result, just allowing everybody to use their own methods according to their conceptualization of the end product. And so it showed why it was important to have a standard work procedure that could produce a standardized work product. We did see a big improvement in the similarity of the pigs when we used just a standard procedure in the grid alone, but having this visual element adds another layer on that. And I even saw some people using it as a template, right? You know, as a template tracing. But even if you weren't doing that, being able to have a picture there, what it actually was supposed to look like, still helped a lot with that. So I guess when you guys think about standard work and what were your thoughts on this exercise? You see, what would you perhaps want to do next if you were going to apply standard work to the pig production?
Use some dimensions.
Okay, so maybe I should actually add some measurements to the standard work process, for instance.
Numerical value.
What?
Numerical value.
Numerical value, so for instance, a certain length of the different lines, right? If it's an inch or half an inch or a centimeter.
Maybe like we'll ask to draw it without the grids.
So you prefer to have it without the grid? Why would that be?
It's like already everyone practiced, right? Everyone knows the procedure and all.
So you're saying we could try removing the grid now and see if that, now we didn't need the grid, for instance?
Or actually give them this and put a traceable paper and just they'll actually draw it just on that.
So actually make the tracing be the intended process, because that really does take out the probability, even a possibility even of error just from simply misreading the standard process. Go ahead.
This is good enough.
This is good enough, yeah.
I would improve the product and add some pink color.
Okay, so maybe we can actually start improving our product, add some color. Maybe you can do a scratch and sniff. Maybe not that. Maybe for the bacon side it would be good, not for the other side. Yeah. Use a copier. So there's a lot of ways you can try to improve this as well. Well, in the last minutes, since we do have a few more minutes, I wanted to try to do another simulation. It's kind of similar to the airplane game that we had previously. However, the focus of this is really, one of the major focuses of Lean is reducing variability. We try to remove variability from our products and processes, and this next simulation really kind of highlights why that's important. So to do that, we're going to form 3 teams of 5, and I think we probably just about have, so if we have one of you guys go over to this team, and then we have 3, and then I think that'll be actually perfect. So 3 teams of 5, we're going to set up a production run. So what is the workstation? Customer. They're going to have.
No, we'll come there. Yeah, we'll come there. Okay.
So they each person is going to get one of these, and then we're going to have the customer is going to have this paper clips in it. One of the each team has 4 workstations and yeah, it's not only closed. It's fine. We do more if the customer runs out. And then we set that up right at
Wife will be the customer. He wants to discuss.
So we're going to do 4 workstations and a customer. Who wants to be the customer?
I'd be the customer.
Okay, a customer needs to be at the end. Whoever.
Or then Alex doing it.
Yes.
Okay, so you're going to get this one. Yes. The customer has a slightly different worksheet than everybody else.
Who's the customer? You're the customer?
Yeah.
Yes, yes.
Depending on which way it's flowing, those may be backwards, so we can address that. All right, who's the customer here?
What does it say? In box. Mac. What is Mac? For the workstation, we have to have what is supposed to be?
Yeah, customer
inbox or inbox and I think Mac.
That is inbox.
And this is Mac.
Mac.
What is it? It's all the same. So
Very good.
I think
they have enough dice to see.
What is it? Mattress or?
Maybe.
It's Matt. It's kind of makes it it's not really a work in process. It's a staging area.
Oh, okay. Custom.
Okay, everybody needs a die.
Customer needs this and you have to put them in the inbox. Playing games?
Everybody takes it. You can pass them down. Yeah, everybody should have
The biggest
a die.
Well, pins in your inbox. 3 pins. And everybody. Yeah. We just have one.
Yeah, for one.
Well, I don't have that.
Okay, so this is we're still getting set up. This is a simulation developed by the Lean Academy that was affiliated with the Lean Aerospace Initiative, originally out of MIT. They've since moved to become a separate organization. They focus on lean education, both developing curriculum that can be used in higher education contexts like this course and also in potential industry training. So our setup for our game is we're going to have a 5-stage system. We are a knowledge process that processes, let's see if we are told what the product is exactly. Actually, that's not going to work. This. No, we're not told what they're. Processing essentially customer orders or customer invoices. So when you're a system, you set up, each person has a workstation where you have an inbox, and that's where your raw materials for the workstation are kept. So those would be your raw materials, and that would go in the inbox. In the material slot, that really is going to be your in process during the production round. So you're going to move that from, you're going to use that for temporary staging, and you're going to move that from your inbox, from your raw material staging place to the inbox of your customer process at the end of the round. So we're going to simulate a production system using a dice, and each, we'll go through one round really slow, but we're going to roll the dice, and that's going to tell you how much your workstation can produce at each cycle. So our first, to just kind of get used to how this works, and then we'll go into actually using the dice, is the first stage. We're going to just do this and pretend that we have rolled a certain roll. So we're going to pretend whoever the customer is has rolled a 3. So in that case, the customer needs to take 3 paper clips from the raw materials stash and get ready to pass that on to the next customer, next process, which would be the mailroom. Don't do it yet, but just get 3 paper clips ready. And next, you're going to see that the mailroom has rolled a 2. So if you're the mailroom, so does everybody know which one they are? I guess based on where you're sitting next to the customer, you know, right? Right. Yeah. Yeah. Okay, good. So the mailroom, you've rolled a 2, so get 2 of your paper clips and move it over to that mat space, which is your holding space for your raw material. So if you're the mailroom, do that. On the PFR, we're going to assume you have rolled a 5. So again, you don't have 5 paper clips, right? So all you can do is use the 3 paper clips you've got in the inbox, move that out to the mat space for your raw material staging. The analyst has rolled a 1, so again, get your 1 paper clip ready to move. And then the payroll has rolled a 6. Again, you've only got 3 potentially, so we're going to just take the 3 and move those into the raw material space. So has everybody done that? Does everybody get ready to do that? So then the end of that is to actually push the inventory to the next workstation. So take everything from your mat space, move it to the next workstation. If you are the customer, go ahead and move it to the inbox of the mailroom. If you are the payer, then move that to your finished goods area, which will give you a cup if you want to put those in there. So now everybody has done that?
And that's what the archive is, what you pass it.
Yes, this is the archive area. So everybody got that? Yes, actually move it over to his inbox. Move it over to his inbox.
Well, it's got it up there.
Or whoever, whichever way you're lining.
It's got it up there for you. The analyst rolls a 1, so you just move one of them.
Yeah, so you're assuming we know the roles. So, yeah. So everybody's ending inventory, it should look like this at the end of this round. We're doing this just to make sure we can get used to the process before we start using the dice. So the key steps there is you only want to select, whenever you roll your dice, you only want to select from your inbox what you actually have in your inbox at the beginning of the round. So don't consider raw material that's getting ready to be handed to you. That's why it's important to wait until the end of the turn to go ahead and move the rest of your material. So for each roll, round we're going to say roll, we'll say stage, and then we'll say move. So you'll know when to actually move the inventory. So does everybody, is there any questions?
Move everything back to 3 each?
No, you keep it, so does your inventory look like this? Yeah. Does your inventory look like this, hopefully? Yeah, okay, good job. So yes, and this is the end of round 1. So the end of round 1, you will want to record how many jobs your workstation completed. So how many jobs, and you might want to do that when you actually move it to the staging area so you don't forget. How many jobs did your workstation process that turn? So it would be, in this case, it would be the roll or a 3 if you rolled higher than a 3. And then you'll indicate now how much work in progress do you have at your station. So how much work in progress, how many paper clips are in your inbox. So that will be for round 1.
So what the completed jobs are the ones in the end of the archive?
Yes, or the ones that you moved this turn.
That's right.
Yeah. 3, and then the amount that you have left is 1. Yeah.
So in case they have only 5 here and if they roll 6, can they take off 5 from both the sides and then they still have a backlog?
Well, they won't. It'll be moved out of the staging area at the beginning. But the thing is, whenever he rolls at the beginning, if he rolls a 5, even if he gets 4 from here, or this person rolls a 4 and can transfer 4, since he only had 1 at the beginning, he can only move 1.
Oh, right. So you can't take from the temporary store. You can only, this Mac area, you can only take from this inbox.
Yes, at the beginning you can only take from the inbox.
This is your raw material.
Same thing, yeah. Yeah, so has everybody, any questions? Has everybody got, or does anybody's end of the day not look like this?
From inbox,
yes.
not from Mac.
Yes, not from Mac.
Okay, has everybody recorded their jobs at their workstation completed? And then the work in progress that you have now? Okay, yours, let's see, yeah, you just indicate, give a little bit more work, worry about this later. You would indicate how many people you could process there, and then you see the state of the map. Yes. Okay, you put the state. Okay. So the payer, the customer, don't worry about the other two columns right now, just record the number of new jobs into the system. Okay, so then round number 2. So again, we're now just doing assuming we did these roles. We're assuming the customer roles at 2, so we get 2 paper clips ready to introduce into the system. This will be the stage. So everybody should be doing their staging according to what their role is here. So everybody get ready, stage your materials, which means either, okay, well, you haven't got past yet. Just stage it and get ready to pass. So staging it means putting it in the material holding area. If you are one of the people that has that customer, you can just hold it until you're told to pass. So stage the number of paper clips that you can pass this time. So customer rolled a 2, mailroom rolled a 5, PFR rolled a 1, analyst rolled a 3, and payroll rolled a 4.
Now we are moving.
So is everybody ready? Okay, so all right, so go ahead and pass then. So go ahead and pass your inventory to the other groups and then record. And then our ending inventory. What?
Is it just raining?
Check whether we are getting that.
Okay, you can go. Yeah, you can go.
Can we move the map? Inbox now?
Yeah, go ahead and do that. Yeah. So is that the one that you got from your supplier? You're the process that supplied you?
Yeah, he gave me 2.
Yeah.
So in previous round, we just put that in map section. Now I'm putting it in.
Oh, because yours is backwards. Okay. Yeah, that's why. Because y'all's line is flowing backwards. So I think maybe try to turn it this way. Yeah.
You're just sitting in the wrong direction.
Yeah. No, yeah. It's flowing the opposite way of this, so yeah. All right.
We're doing what our customers say.
Yeah. All right. So everybody got everything recorded at this time? Again, if you're the customer, don't worry about getting the pay information. We can get that from the pay as well. So here's an example of what this would look like if you were the analyst. So hopefully if you're an analyst, your data looks like this. For the customer, again, we get this data from the middle column data from pay. The total work in progress, we can always use everybody's sheets to add those up. We know that we started originally with 12 pieces of work in progress. All right, so any questions about how this works? So we're going to add another complication this time. Yes.
Actually, I don't understand.
What? Okay, so this WIP, so each person has a worksheet that looks like this. Each workstation has one. So each workstation should be recording the number of jobs that you pass to the next workstation at that round. You should also indicate what's in your inbox at the end of that round.
Next workstation.
So does that match your data? The analyst.
So what will be the job completed?
Okay, now the customer's sheet looks a little bit different. Oh, this doesn't advance. Okay, so I did full screen it was right. Is there a full screen mode? So the customer's does look a little bit different. So the customer, again, I would just worry about filling out the first one right now. At the end of the simulation, you can get the data from the pay, and you get the data from the so you're just to indicate the number of new jobs that you introduced for
Everybody
that
has to
round.
have-
Okay. Okay. Does anybody have?
Everyone has to roll at the same
Do it.
time. Everyone has to roll at the same time, right?
Yeah, so I guess as we get ready, we'll start. So we'll do this first one real slow. So everybody roll their dice, whatever they get from the die. 6. Okay, so depending this time on what you got on that roll, now actually stage your material to get ready to pass it on to the next group. So stage it.
What about the last person? The pair. Like I got 6.
You got 6, well you gotta use what you got and what you have.
I mean, I have 3 and he just gave me.
Okay, you can't use the stuff he just gave you, but you can use anything you had at the beginning of the round.
Okay.
Yeah, okay.
Okay, all right.
All right, so get set. Now go ahead and pass your material on to the next person, so everything should be in that first inbox area. And then do your recording of your data.
Yes, we are here. We are the second time. This is the second time. Yeah.
So do everything going there? Okay. Yeah, you can start rolling. I guess the major thing is trying not to get ahead of each other, because you've got to remember you can only use the material that's in your inbox at the beginning of the turn to pass on to the next person. You can't use anything you're handed during the turn. So it'd probably be easier if we just try to keep everything. So we'll try to go a little faster then. Roll. Everybody roll. All right, stage. Get things ready to pass.
I don't have enough inventory.
Go ahead and pass.
What is that?
If I have 6,
Well, you can only use what you got, right? So you got 3, so you got to use 3.
Wait for the last person to roll. You guys are rolling. When I started my first round.
I'm sorry.
Wait for the last person to finish.
Okay, so yeah, y'all can go on now on your own. Just make sure your line stays synchronized. And we're going to do 20 rounds. Once we're done with the 20 rounds, we're good.
No, because I have 5 and I got 6. I
But you do all whatever you have inbox, right?
Yes, I have 5 in inbox.
But then how much?
5. I gave him 5. And
That's it. But then you have 3 sorry, you have gone far. I guess. If you don't have the inbox, when you have to get to this one as well, that you can use that one
Now I can tell.
down fourth round. Down to fourth round.
No, this was
Down to fourth round. Better somebody say, yeah.
You finish 4th round.
Yeah.
Wait for it.
So that
Wait for it. One. Okay.
How much?
this is another
5 hours.
95. I have the 5 of it.
Let's see, you can sync, yeah.
Okay, so roll the 5.
Okay, round 5.
Roll round 5, right?
Uh-oh, we got some quality issues.
I'm passing.
Pass.
3. So if I have just 1 in my inbox, my dice shows 2.
But still you can put only 1.
Okay. But I have to give him more. Roll again.
Wait.
This one?
Roll and stay.
Okay, this goes into inbox.
You can see like a very few jumps because it's all on the chance of this. I thought you guys were ahead of me. No? Well,
We are saying that round
okay, well then.
Kommen jetzt noch 2 Tage. Möglichst alle 6. Julian, du, nee,
So you're good. Did you guys finish? Yeah. You finished yours? Okay, so if you can start calculating the totals at the bottom of your spreadsheet, bottom of your worksheet, yeah, the totals. And then have the customer can go calculate the, with pay, these overall values as well.
Yeah, I sent you the
done the work in progress is the last one. Why not do it?
Oh, actually, yeah, sure.
Did we have some or only the last one? Okay.
So it seems like all the teams have finished and are calculating at this point. So calculate up these values A through E for your each workstation, and then for the customer, your workstation worksheet looks a little bit. You'll want to communicate with the pay station in order to be able to complete your worksheet. Yes.
I've got a question for day 20. Your WIP, is this ending WIP? Did we have some
For line 20, that would be the ending.
Genau, jobs completed.
Calculated.
We usually invite over 20.
Okay, on work in progress?
On work in progress?
48. 55.
This is postponated work in progress? These average work in progress is
Average work in progress is just taking
Genau, ich hab auch
the
die
total
Aufgabe.
width and dividing by 20, so it's going to 20
in our sheets
period.
it's showing ending work in progress.
Oh, it's different? Oh, for the job. Yeah, this is for yours as well. It's different.
No.
Yeah, this is the one for the customers.
Okay.
Theirs is slightly different.
And for us, it will be the last 20th column, right?
Correct. Yeah. And I'll double check that that's the same here. But yes, that would be the last one. 20.
10 divided by 8 is 1.
Although I think that if you divide it by 20, it's going to give you a slightly wrong number because you have that first with entry of 12. So you actually want to divide it by 21 for this customer sheet. Just for the width one.
I was thinking 1,599.
So we'll want to, for the customer worksheet, we'll want to adjust this formula here to be 21, so you should actually have 21 entries if you have this initial 12. If you don't, then you could use
It's divided by
20.
B, right? B is 2.8. My preference is not by
Relativ konstant gegen Ende.
Does anybody have data yet, or data for the workstation? So got some data for the workstation. Does any customer have any data yet? Any customer workstation have data yet? So let's think about this system. So from the perspective of each workstation, again, we were asked to calculate a number of measures, the total number of jobs we completed during the 20 time frames, the average number of jobs we completed each day. So we took our total, we divided it by 20, a utilization method, which we use our jobs actually completed based on 3.5. We'll talk about why 3.5 is there in a minute. Our ending work in progress, which would be our entry here on day 20, and then our estimated flow time, which is going to be our ending work in progress divided by jobs per day. And again, we'll talk about why we have that relationship there. But if we think about, I guess, jobs completed per day, do we know what the value should be for the capacity of each workstation is?
620. That's the maximum.
Okay, yes, the maximum for each workstation over the entire 20 days would be 6 times 20, right? On average, what would we expect the workstations to produce?
3 times 20. 3 times 20.
The max is going to be 6 times 20, or 120. The average, so this would be expected
3 times 20.
production. it 3 times 20? That's a good thought.
Yes, that was 3 times 20.
3 times 20?
Yes.
What is the average dice
It's 3.
roll of the die?
3.
3 or
Average is around 3.
3.5.
it actually ends up being 3.5, right? So we have to take 1 plus 2 plus 3 plus 4 plus 5 plus 6. Divided by 6 would give us, let's see, 3, 6, 10, 15, 21. 21 6. So it gives us, actually that doesn't give us 3.5. What am I doing wrong with this? Am my math maybe incorrect?
It's 3.5.
It gives 3.5.
It is 3.5. Okay, I'm obviously too tired then. 3.5. Okay, because it's 3.5. So it is actually 3.5, not 3. Although our intuition actually says it would be 3. So it's 3.5. So we'd expect our average production to be 3.5 jobs per day.
Into 20.
So times 20 would mean how many would we expect? 70. We expect to complete 70 total jobs at each workstation, and also for the production line as a whole, because our production line, each job, workstation had the same capacity. So I see some people smiling. So is that what you actually got?
No.
No?
Very limited.
Okay, so let's just let's go. I guess we'll say the team in the back, for instance, that we'll say y'all are team 1. What was your overall production for your line as a whole?
55.
What?
55.
55. So you had 55 total jobs produced for the line. And what about the team in the middle? So 50. 50? And then team up front, we'll call you team 3. 63. So we had our high value there, 63. Actually pretty close to the average there, but a little bit less than the average. So why do we think we had the teams overall produced less than the average, and sometimes more significantly so? So why did we have this issue?
Something to do with these things.
Okay, so go on. Something to do with the dice. Go ahead. Yeah.
It's just luck.
It's just luck. So luck, variability.
Yes.
For each workstation.
For each round, you use the minimum number of.
Go ahead.
But there's still some left in the buffer, so it can't be 70. Or 70 isn't the average right now, considering that there's still some of.
But we don't have more than 20 days. Right?
Okay, so that's a good point. So you're right. So the fact that something's left in the buffer tells us we're not producing to our maximum potential, or at least if we had some left in the buffer at the time, we expect only to have 3.5 on average, right, in the buffer. Yep. Okay. All right. So what other comments? Yeah.
For each round, we are actually passing the minimum number a person roles in the team.
Okay. So one thing we see is that what we say basically delays accumulate, advances do not. So we're constrained by the minimum roll that someone had in the roll, and we weren't when we had a roll that was higher than the available inventory, we couldn't fulfill that demand, right? So in the case, for instance, when we saw at the beginning of the simulation, we had a couple rolls that were greater than our starting inventory. We actually made this a little bit of unfair information from the start, right? Because you had less inventory to start with than was going to be your average demand, so you had 3 only, and we know the average demand is 3.5 for each one, so we had a little bit of an unfair situation, but not by much. But when you see that we had several rolls here, we had a 5 and a 6 where we had above average production those rounds that we could not take advantage of because we did not have inventory. So we were not able to use those higher rolls, so we ended up being constrained by the lower rolls instead. So we're actually producing less than capacity. So we see this combination of variability actually creates interesting dynamics. Again, and this actually is true for production systems, assuming unless you have a large amount of inventory in starting the system, and we know that that has other difficulties associated with that, is that we have this case where we have, again, our delays accumulate, advances do not. So we can't take advantage of these higher rolls that we had. We only can take, when we have a lower roll, for instance, we had the roll of a 1 for the analyst, that puts pay at a disadvantage, right? Because pay at that point in time had already passed all of their inventory into the archive, had already processed all of that because they had a roll of 6. Now at the start of the next round, they only had 1 to work with. So that is that there ends up being a shortfall, wasted capacity because of that phenomenon that's occurring. What else did you experience from anybody feel frustrated at all during this exercise? What was the source of frustration?
Confusing. Yeah, in the beginning, yes.
A little bit confusing. Yeah, the simulation itself. Did anybody feel frustrated when they didn't have enough inventory? If you rolled a 6 and you're like, oh, I only have 2, I can't. Yes.
I got more than I could pass. I always like 2, 1, 3,
Uh-huh.
and I got 5, 4, 6.
Oh, so yeah, so you ended up with a lot of inventory, right?
I did.
And then everybody, so you were holding up holding up
I
all
had
the inventory.
12 at the end.
At 12,
in
yeah.
inventory.
Exactly. Yeah.
18 for
Okay.
I was
And
trying
it's
to
just
reduce
one,
the work in
so
progress, but
that's okay.
I'm getting equal amount what I'm sending in.
Oh, okay, so you actually had fairly even flow, which is actually what you kind of would want, right, in essence. So what we'll see is, and I'll look at your data and do some compilation of what that actually looks like. What we see is a typical simulation looks somewhat like this. So we start off with basically, we saw this as well in our airplane simulation, that our inventory tends to move through the system in waves. Right, so this is actually a graph of the inventory. This is obviously for a lot more than the 20 days that we use, but inventory in the systems actually was using a computer software package that simulates this process. So we noticed that you used to have initially a large build of inventory in the mailroom. Eventually that gets passed on, which the mailroom with the one that was immediately after the customer, immediately that gets passed on to the other workstations. Please do turn in the, or I guess anybody have any closing thoughts on this simulation before we end? All right, so please, you can keep your paper clips if you want. Please do turn in the dice, since those are actually Dr. Mattis's. And then I'll see you again next Thursday.